Good morning, ladies and gentlemen. My topic today is about the development of tunneling over the past 40 years in China. So I would like to share with you about the outline of tunneling in China and challenges and achievements over the past 40 years and the future developments. In the end, I would like to make a summary. So regarding the tunneling in China over the past 40 years, I would like to share you the numbers and the progress. I think maybe everybody knows China's 40 years of reform and opening up to the outside world has brought huge changes to this country since 1978, including China's booming economy, huge investment in infrastructure, of course, including a dramatic increase in Chinese people's income, important, and of course, including dramatic development in tunneling. That's what I'm going to talk about. So here you can see some numbers by the end of last year. So China has built around 36,000 kilometers transit tunnels, including railway, highway, and metro, but no includes the tunnels for other purposes, like water transfer, utilities, and other purposes. And at the same time, around 20,000 kilometers tunnels under construction, and another 20,000 kilometers tunnels to be built in the near very future. So here, I would like to share with you the slide. This slide shows the numbers over the past 40 years. So you can see most of the tunnels, existing tunnels, were built over the past 40 years, especially in the past 20 years. It's quite challenging for me to summarize the progress of tunneling over the past 40 years because a lot of things happened, but I would like to give you some keywords. So keywords number one is about amount. So huge amount of tunnels have been built, around 45,000 kilometers for transit tunnels and other purpose tunnels. Especially in the past 5 years, a lot of tunnels have been put into operation, including railway, highway, and metro. And keywords number two is about innovations. A lot of innovations have been made on the investigation, design, construction, and manufacture. So because of the time limit, so I cannot go to very detail, but keywords number three is about the challenging. Lots of challenge projects had been built, including long, deep, large, high, and very compressed tunnels. So I'd like to share with you the challenges and achievements over the past 40 years. A lot of tunnels, long tunnels, deep tunnels, large tunnels, high tunnels have been built. Regarding the long tunnels, so this is the current longest tunnels in China. So the longest railway, longest highway, and the longest water transit transfer tunnels. So I think the longest one in the world at the moment, I think it could be 283 kilometers long tunnel. It's for water transfer. Yeah, this is single tunnel, not many tunnels together, only single tunnel. It's quite long. I think for the challenges building these long tunnels, I think including uncertainty of geology and the long construction time because the tunnel is so long, as well as the disaster prevention during operation. So I will show you how we deal with these challenges. So first one, we use geology prediction during tunneling because it's quite challenging to know exactly the geology before excavation. So it's very important, and now it's a compulsory procedure to do geology prediction during tunneling. For the conventional method, that means drill and blast, it's quite easy because you can do from the excavation phase, but during tunneling by TBM, by machine, it's quite challenging because you cannot see the excavation phase. So in this case, we need a special geology prediction system. We developed two different systems. One is we call it induced polarization method, and we have the sensors installed in the cutter head and also in the backcut system. So we can detect the geology ahead the TBM automatically. And another system is no any sensor installed in TBM, because some TBM manufacturers, they are not happy to have astral sensors to be installed in the TBM. So this system without any sensors in the cutter head. But we use the vibration when TBM cutting rock, the vibration as a signal. And then we can detect the geology ahead. So both this system has been used quite a lot in different projects in China. And the other solution is about repeat construction. Actually, there's no single solution for different long tunnels, but I would like to share you two cases. One is Wushaolin tunnel. It's 20 kilometers long, 2 parallel tubes. Because this tunnel was the bottleneck of a very, very busy railway. So that means the earlier operation, the better. So we use 13 inclined shafts, different inclined shafts, to speed up the construction time. So the construction time was shortened from 5 years to 2.5 years. So after 2.5 years, these 20 kilometers tunnels already finished and put into operation. That's due to we use more assets. Another case is Dahuofang water transfer tunnel. This is an 85 kilometers long tunnel. And the geology here is very poor, very fractured, a lot of groundwater. But this is quite shallow in this part. And in the rest of the part, the rock is good, but it's very deep. That means it's difficult to have more assets, to have more pilots. So as a result, we use string and blast convention method for this part with more inclined shafts. And this we use 3 TBMs, each for 20 kilometers. So the construction time for the excavation only took 3 years. And the maximum advance rate by 1 TBM is more than 1,000 meters per month. Regarding deep tunnels, of course, many deep tunnels have been built. I think the major challenges for deep tunnels, including high ground stress, heavy water inflow, and geothermal problems. I will share you two cases. So this is a Jinping Stage 2 hydropower station. I think many of you already know this project. It was very challenging, and there were 7 very deep and very long tunnels. And the maximum depth is 2.5 kilometers deep. So it's very deep. During the construction, very serious rock burst, as well as water inflows with very high water pressure happens. You know how much the pressure? It's around 10 megapascal. That means the groundwater is more than 1,000 meters. So it was very challenging. So you can see from the picture. And sometimes it's very difficult to deal with these water inflows with such high pressure. And sometimes the water inflow from here is so strong. And you can't stop it with a single solution. So we drill more boreholes to release the pressure. So because that's the fault, and this is the major water inflow, so more boreholes to release the pressure, and then you can stop here by grouting one by one. And finally, you can stop the water inflow. And this is more or less the same philosophy. Of course, for the deep tunnels, rock burst is quite common. And for this project, we have around 11 kilometers tunnels have this kind of problem. So we use repeatedly maintaining the surrounding rock and blasting for stretch release, as well as strengthen support to maintain to adopt the deformation and to maintain the structure. And finally, that project was completed finally and put into operation in 2014. Another case, the deep tunnel is Gaoli Gongshan. This one is under construction at the moment. So you can see here, this part, the geology is quite good, and this part is quite challenging, it's quite complicated. So we use 2 TBM for this part and conventional method for this part. The major challenge for this tunnel, many challenges. One of them is the geothermal problem. So you can see here, actually in this area, there are a lot of hot spring. How hot? You can imagine. It's nearly boiling water. It's more than 90 degrees. So you can use it for cooking without problem. So, but for tunneling, it's very challenging, you know. And but luckily, in tunnel, the temperature was it's hot, but not so hot. But it's still a big problem for tunneling. So we use, of course, ventilation and cooling during the construction. And also we use grouting to stop the water because the groundwater is coming very deep. The very hot water is coming from very deep. So we stopped it by grouting. And also we consider the durability of the shotcrete and lining. During the construction, if the temperature is very hot, then usually the quality of the concrete, the shotcrete, should be a problem. So we need to sort it out. And this tunnel is now under construction. Regarding large tunnels, we use different methods to build large tunnels, including conventional method, TBM, immersed tube, etc. So I will share you several interesting projects. This one is a Hong Kong, Zhuhai, Macau immersed tube. It's the very largest immersed tube at the moment. So it's linking Hong Kong, Zhuhai, and Macau. So there's a video film, a short video film I would like to share you, but I don't know how to do it. Okay, done. There's a voice. Excuse me.
Connecting Hong Kong and Macau at west, and its total length is 55 kilometers. The island and tunnel engineering construction consists 2 artificial islands with areas 100,000 square meters of each and one 6.7 kilometers long immersed tunnel, which is so far the only one deeply buried immersed tunnel, as well as the longest highway immersed tunnel in the world.
Oh, okay. So because the video is quite long, but I just cut a very short part. So this immersed tube is linking by 2 artificial islands, so around 6 kilometers long, and it's quite big one. It's around 38 meters wide and 11.4 meters height. And this one was already finished and open to traffic last October. And this project was the major tunneling project of ITA last year. And at the same time, we have another similar project under construction at the same time. And so you can see this is a Hong Kong, Zhuhai, Macau project. I just show you. And this is the Shenzhen-Zhuhai corridor. Yeah, that one. I'm sorry, this is not so, this one. This is Shenzhen, Zhongshan, this is Guangzhou. So this is another corridor under construction. Also combination by bridges and immersed tube. That's another artificial island. And this one is even longer and bigger than Hong Kong, Zhuhai, Macau immersed tube. And it's a steel shape. It's not a concrete structure, it's a steel structure. So you can see it's even bigger. It's 46 meters wide, 9 meters bigger than Hong Kong, Zhuhai, Macau, and 4 lanes for each. It's under construction. It's also quite challenging. We also use conventional method to build large tunnels. So here you can see it's Beijing and Zhangjiakou. These are for the high-speed railway, built especially for the 2022 Winter Olympic Games in Beijing and Zhangjiakou. So there was a very long tunnel here, and just under the famous Great Wall. It's around 12 kilometers. And in this very long tunnel, there's a very big underground station for high-speed underground railway station under construction. And it's very big with a very building area about 36,000 square meters. And the construction time for this railway is 3.5 years. Oh, sorry, this picture is no, right? So you can see that that's the plan view about this station and the profile. So this is for the tunnel. The bottom level is for the train, and inbound corridor and outbound corridor. So 3 levels. So totally there's 78 tunnels under this station. This is for the large span. And this is under construction, and this is after excavation. And we also use TBM to build large tunnels. So this is the case under the Yangtze River. So also 2 tubes, but it's a combination with road tunnel and the metro tunnel. So on the top is 3 lanes per road, and underneath is for metro, line number 7. So this is in Wuhan. And this project already opened to traffic last October. And at the same time, we have another similar project now under construction in Jinan city. Of course, for this kind of design, we need to optimize the use of the space, because the bigger of the tunnel, it will be more expensive. So we need to optimize the use of the space. We use this for the smoke extraction for the road, and we use this for the smoke extraction for the metro tubes extraction. So we need to optimize the use of the cross-section. Regarding the tunnels at high altitudes, I will show you 2 projects. One is for railway, and the other one is for highway. So this is a Qinghai-Tibet Railway. I think this is the longest and the highest railway, because the length of this is 1,100 kilometers long, but 960 kilometers is about altitude of 4,000 meters. And the highest point is more than 5,000 meters. And a lot of challenges. So you can see this is I think this could be the highest railway tunnel, because the altitude is nearly 5,000 meters. And the construction time is only 5 years. Regarding the tunneling at very high altitudes, I think the major problems, including freezing and soaring, and also habitat problems. At the high altitudes, so lack of oxygen, so even the machine, even the equipment is not so efficient. So you have to use electrified equipment as much as possible. And for the diesel power equipment, sometimes the efficiency is not so good enough. So also we need to consider about the health of the laborers, because lack of oxygen. So we also use the oxygen generating station to supply enough oxygen. It was very challenging. Another case is a highway tunnel. So you can see the blue one was the old highway, and the red one is the new solution with tunneling solution. So it was so difficult, because the road was so dangerous, especially in winter time, deep slope. But in summertime, debris flows, landslides, it was so difficult. So it was several accidents due to the very critical situation. But now it's very easy by tunneling solution. Only in 10 minutes, 9 kilometers, a very comfortable situation, and sea level is reduced from 5,000 to 4,300. So I think it's for tunneling. I think tunneling improves people's life and also save people's life. And I would like to share you some complex tunnels, but I don't think we have time to go to detail. So a lot of tunneling in complex geology, including karstic, thermal gas, squeezing, flowing sand, losses, etc. And we also built quite a lot of tunnels in challenging urban areas, including underground interchanges. We use a lot of interchanges, but usually it's bridge interchanges, but we built several underground interchanges and other tunneling in very sensitive grounds and very sensitive buildings. So regarding the future development, I would like to share you two very challenging projects. One is Tibet Strand Railway. It's around 1,700 kilometers long. So you can see, the geology is very challenging, and 80% will be in tunnels. So the challenging for this project, including very complicated geology, faults, seismic, and thermal forest, landslide, and other geology disasters. And it's, the condition, the weather condition is so difficult, because the altitude. So there will be a lot of long, deep, and high tunnels to be built. So I will show you that's some of the long tunnels. The longest one is 42 kilometers, and several other tunnels. So I think the total length of the tunneling could be around 1,000 kilometers. So another project is undersea tunnel, linking Dalian and Yantai. It will be 123 kilometers undersea tunnel. Also very challenging because the geology here also complicated and seismic area, and it's so long. So we need to consider how to ventilate it. We need to consider how to prevent from disaster, etc. So these two projects will be built in the future. So finally, great achievements have been made on tunneling over the past 40 years in China. I think these achievements would not have been possible without knowledge sharing and experience sharing and even encouraging for the successful projects internationally. While the development of tunneling technology in China also contributes to our international tunneling industry. Not only in China, I think in other parts of the world, I think we have more challenging projects to come. So I think we International Tunneling Association and we International Engineering Society, we need to deal with these challenges with even longer, even deeper, even larger, even more complex tunneling projects together. Thank you. I would like to thank you for your attention. Thank you.